So moving on with this presentation. So we talked about a little bit about these math library functions and the fact that they're written by someone else, they're not written by us. Okay. Example with character classification, you can look at different character types. I'm not going to dwell on this right now, but this is just an example which we will most likely revisit in the future. Function parameters. So here's an example of a function named square, right? So let me, I just take this portion right here and copy and paste before return to talk about this a little bit in greater detail. So I will preserve my pause because I need it, right? And then just copy and paste this. Here's an example of us defining our own function. Its name is square, and obviously, just like we had square root, square is essentially the opposite type of work. If you would like your function to work with your own input parameters, you can include input parameters between these opening and closing parentheses. All right, and they look very much like function, like variable declarations. Right? You could do something like this. This looks like a creation of a variable. But this time, instead of doing it here, I do pretty much the same thing inside these parentheses. It's int x, integer variable named x, and it stays between these parentheses, and it doesn't need the semicolon, right? So semicolon here would be a syntax error. Don't do that, all right? Now there's an integer in front of the name of the function. So let's talk about the function, the structure of the function. All right. So I'll just copy this back to my journal. So hopefully this time I don't do something that it crashes. I'll paste this in, and again I will resize my text to make it bigger so that we can see what's going on here. All right, so here it is, taking from our code. So this looks very much like an identifier, and this is where we normally begin looking at things, right? So this is function name. The next piece here is called, right here, inside parentheses, our function parameters, and this piece right here, this is a little bit more sophisticated than I need. This is called a return type. So function can return values back. So these are pretty much all components of the function definition, right? So what we are looking at here is function definition. A function definition means that the function is fully defined. The compiler will see this function definition and will know exactly that this, what compiler will do here, it will search for the name first. It will say, oh, I have the name or identifier. This identifier has opening and closing parentheses, which means this identifier is a function name, and therefore it will start looking for the type of parameters that the function takes and what is the return type. What happens inside this function is that we have a statement. How do I know that it's a statement? Because I look at the semicolon, right? It tells me, oh, there is a programming statement. Our programming statement. And this programming statement uses this keyword return. Return is a vehicle to specify what this return value should be. the type is integer, but we have to compute it. And the return statement here, it does exactly that. It computes x multiplied by x. This asterisk right here is the multiplication sign, right? So, and this portion right here is pretty much an expression, right? Expression that uses variable x and multiplication sign, and the result of expression, remember we said the result of this expression is stored like a temporary value. It gets computed, right? So for instance, if I call the square, right? If in my main right here in my main function, if I say integer result equals square 5, okay, passing an integer 5, x will be initialized with the value of 5, right? So this value of 5 will be used to initialize the initial value of variable x. And then of course x will be equivalent to 5. 5 times 5 is 25, and so this temporary value that we compute inside this function is 25. Normally the temporary values like this, like I'm telling you, are stored directly in your CPU. Your CPU has temporary memory or extremely fast built-in memory called CPU registers. And so this value will be stored in one of your CPU registers. And when the function returns back to the main function, right here, the CPU will populate the result variable with this temporary result or temporary value that it holds in the duration that it takes to return from square back to function main. Now this graphic here, which is extremely simple, like this picture right here, it sort of like demonstrates. Let me actually try copying it. Copy image, and maybe I can insert it directly into my notes right here. Okay, very good. So I can try resizing it maybe. Yeah, that works. Okay, so what this little picture demonstrates here is that, of course, this is somewhat what we can refer to as a sequence diagram, right? So we show up, the program begins executing function name, and this is our timeline. So execution like goes this way. So down goes the time. And then we hit this function call to square, right? So if you look at the actual code, right? So right here we say, let's make a function call to the function named square and pass a value to it, okay? And this, this graphic here demonstrates simply that it takes a while to do this computation. So while this computation takes place, so we actually do make a call into square, do our computation. Remember, it's like x times x. That's what it does, right? So then it also takes a while for us to return back and populate the result. But while this takes time to do this computation in square, nothing happens in main, right? So there's absolutely nothing that happens inside the main function. It just waits for square to return, because we're just running this single thread of execution. Every time we make a function call, life stops. It's inside main. We make a function call and we let the square to execute, do its thing, then return the result, and then main happily continues, right? So in the continuation of main, we can add the same thing. We could add, like a statement like std cout and print whatever we want and display the results and things like that, right? So we can do more things here, and I still have my IO stream include in this program. I kept them on top so that I still have access to C out. Now, if I forgot to include IO stream, of course, STD C out device is no longer available, and I'll get a compiler error.